For more than a century, the gemstone market followed a simple hierarchy. At the top were diamonds, recognized, traded globally, held in the most prestigious collections in the world. But something unusual has been happening quietly among serious gemstone collectors. Some of them are shifting their attention away from the most famous stones on Earth and toward a group of gemstones that most buyers have never even heard of. Many of them come from one continent, Africa. Stones discovered in remote mountain belts, narrow geological corridors, and deposits so limited that some may never be found again. A few of these gemstones now appear in collections that once held only diamonds, and the stories behind them are far more unusual than the market ever expected. Starting with a gemstone discovered almost by accident, in the same hills that produced one of the most famous gems of the modern era, ranked 10th, Merelani mint garnet, the discovery that should have been ignored. In the foothills of northern Tanzania, not far from Mount Kilimanjaro, one of the world's most famous gemstone discoveries reshaped the jewelry market in the late 20th century. That discovery was Tanzanite. For decades, the narrow Merelani hills became synonymous with the deep violet-blue crystals that Tiffany and Company helped introduce to the world. Miners searched relentlessly for that one stone. But hidden in the same geological corridor, often mixed into gravel piles or overlooked in sorting trays, another crystal quietly appeared, small, pale green, almost too subtle to notice. For years, these stones were treated as little more than secondary material from the same mining belt. Parcels containing them often passed through trading channels without attracting much attention. Yet gemologists eventually realized something unusual. The color did not match typical green garnets. Instead of the darker tones associated with many garnet varieties, these stones displayed a bright, mint green brilliance, caused by trace amounts of vanadium inside the crystal structure. Under certain lighting conditions, the color seemed to glow with a freshness rarely seen in the garnet family. The stone eventually became known as Merelani mint garnet, named after the same region that produced Tanzanite, and the geological story behind it is remarkably narrow. The deposits appear in a small metamorphic belt that has produced only a limited amount of material since the stones were first recognized by collectors in the 1990s. Unlike more widely distributed garnets, Merelani mint garnet forms under very specific chemical and pressure conditions that are not commonly replicated elsewhere. That scarcity did not attract immediate global attention. Instead, interest grew quietly within collector circles, particularly among those already familiar with the Merelani mining district, because collectors who study gemstone geology tend to recognize a pattern. When two unusual gemstones emerge from the same narrow geological corridor, the probability of large undiscovered deposits becomes increasingly unlikely. In other words, the supply may already be close to its natural limit. Today, Merelani mint garnet remains far less known than the gemstone that made the region famous. Yet among collectors who focus on unusual garnet varieties, its appeal lies precisely in that contrast. A gemstone discovered in the shadow of a global icon. A crystal that spent years overlooked in the same soil that produced one of the most celebrated gemstones of the modern era. And that quiet origin story is exactly what makes Merelani mint garnet a fitting place to begin this list. Because sometimes the most interesting gemstones in the market are not the ones that captured attention immediately, but the ones that were almost ignored. Ranked 9th, chrome tourmaline, the geological anomaly. Not every gemstone discovery begins with excitement. Some begin with confusion. In the late 20th century, miners working in East Africa began encountering small crystals with a color that seemed strangely familiar. At first glance, the stones resembled emerald. Deep green, intensely saturated, almost glowing under natural light. But something about them didn't match. Emeralds are part of the beryl family, a completely different mineral structure. These crystals, however, belong to another group entirely. They were tourmaline, and not just any tourmaline. What made these stones extraordinary was the trace element responsible for their color, chromium. The same element that gives emeralds their famous green hue had somehow entered the crystal lattice of tourmaline, producing a vivid green rarely seen in the species. The result was a gemstone now known as chrome tourmaline. Unlike emeralds, which often contain internal fractures created during their formation, chrome tourmalines tend to develop with fewer structural weaknesses. This allows them to display a brilliance and clarity that can appear almost electric when properly cut. Yet despite its remarkable color, chrome tourmaline never became a mainstream jewelry stone. The reason lies in its geology. Deposits are extremely limited, primarily found along a narrow mineral belt stretching through Tanzania and parts of Kenya. Production has always been inconsistent. Some years yield small quantities, other years produce almost nothing at all. That unpredictability has kept chrome tourmaline largely outside the commercial spotlight. But within collector circles, that same limitation has made the stone increasingly intriguing. Because gemstones colored by chromium often share a similar characteristic. Their most vivid examples tend to emerge only under very specific geological conditions. Conditions that are rarely repeated across multiple regions of the planet. In other words, the environment that produces chrome tourmaline is far less common than the gemstone itself. And that geological rarity is exactly what has begun drawing attention from collectors searching beyond traditional stones. A gemstone that shares the color chemistry of emerald, yet belongs to an entirely different mineral family. A green crystal born from a geological coincidence so unusual that even experienced gemologists initially struggled to explain it. And once that story becomes part of the stone's identity, it rarely remains obscure for long. Ranked 8th, Winza sapphire, the stone the market ignored. In the world of gemstones, discoveries do not always announce themselves clearly. Sometimes the first reaction is uncertainty. That was exactly the case in 2007, when miners in central Tanzania began pulling unusual sapphire crystals from the ground near a remote village called Winza. At first, the stones looked inconsistent. Some appeared red, others leaned toward orange. Some displayed hints of purple or deep pink. For traders accustomed to the clean color categories of traditional sapphires, blue, yellow, or padparadscha, the Winza material was difficult to classify. Many stones contain visible silk inclusions and irregular color zoning. In a market that often prioritized clarity and uniform color, these characteristics initially made the gems harder to sell. For a time, parcels of Winza sapphires circulated quietly through local trading channels. Some were mixed with other sapphire material. Some were treated cautiously by dealers who were unsure how collectors might respond. But within gemological circles, something about the stones began attracting attention because Winza sapphires displayed a combination rarely seen in a single deposit. First, the colors often contained natural red and pink saturation, shades that are typically associated with rubies rather than sapphires. Yet the mineral chemistry clearly placed them within the corundum family as sapphires. Second, many crystals show dramatic internal patterns, with color bands moving through the stone like geological fingerprints. Rather than appearing as flaws, these structures revealed how the crystal formed deep within the earth. Every stone looked slightly different, and that difference slowly became the stone's defining identity. Collectors who appreciated geological uniqueness began viewing Winza sapphires not as imperfect stones, but as natural records of the environment that created them. Instead of uniform beauty, they offered individuality. Instead of predictable color, they displayed complexity. That shift in perception changed the way these stones were seen. Today, Winza sapphires remain relatively obscure compared with the famous sapphire sources of Kashmir, Burma, or Sri Lanka. Yet within collector communities focused on unusual sapphire varieties, the Tanzanian deposit represents something far more interesting. A gemstone that the market initially struggled to understand. A discovery that looked inconsistent until closer examination revealed a completely different kind of rarity, because sometimes the stones that appear imperfect at first glance are simply waiting for the market to recognize what makes them extraordinary. Ranked 7th, Namibian Demantoid garnet, the collector's secret. Some gemstones become famous almost immediately. Others take a completely different path. They circulate quietly through specialized markets, known mostly to gemologists, collectors, and a small number of dealers who recognize their unusual properties long before the broader jewelry world notices. Namibian Demantoid garnet belongs to that second category. Demantoid garnet itself is not a new gemstone. The variety was first discovered in Russia during the 19th century and quickly became prized for one remarkable characteristic: its extraordinary ability to disperse light. Dispersion is the optical property that causes a gemstone to split white light into flashes of spectral color. Diamonds are famous for it, yet Demantoid garnet possesses something unexpected. Under certain conditions, its dispersion can actually exceed that of diamond, producing vivid flashes of green, yellow, and orange light that appear almost electric when the stone is moved. For decades, Russia remained the most famous source of Demantoid garnets, but later discoveries in Namibia introduced a new geological chapter to the story. The Namibian stones formed in a different environment, often within serpentinite-rich host rock. As these crystals grew, microscopic fibrous inclusions sometimes developed inside them, structures that collectors now refer to as horsetail inclusions. Under magnification, these inclusions resemble delicate golden threads spreading outward from a central point within the gem. Rather than being viewed as flaws, these patterns have become one of the defining signatures of natural Demantoid garnet. They act almost like geological fingerprints, revealing how the crystal formed deep within the earth millions of years ago. Because of this, many collectors actively search for stones that contain visible horsetail structures. They provide a rare combination of beauty and authenticity, evidence that the gemstone developed naturally rather than being artificially enhanced. Yet despite these remarkable characteristics, Namibian Demantoid garnets have remained largely outside mainstream jewelry marketing. Part of the reason lies in production. Deposits tend to produce relatively small stones, and mining output has always been limited. Without large quantities entering the market, the gemstone never received the same promotional attention that propelled diamonds or sapphires into global recognition. But inside collector circles, the story looks very different, because experienced collectors often focus less on marketing and more on the underlying geology of a gemstone. And when a stone combines unusual optical performance, identifiable natural inclusions, and limited geological distribution, it rarely stays unnoticed forever. Namibian Demantoid garnet may still appear obscure to most jewelry buyers, but among those who study gemstones closely, its reputation has been building quietly for years. A brilliant green crystal whose flashes of color can rival the very gemstone that once defined luxury itself. And for collectors searching beyond traditional stones, that quiet reputation makes it one of the most intriguing discoveries to emerge from Southern Africa. Rank 6. East African color change garnet. Most gemstones behave in a predictable way. Place them under light, and their color remains the same. Emerald stays green, ruby stays red. Diamond reflects white light into flashes of spectral fire. But a small group of gemstones behaves very differently. Their color changes depending on the type of light illuminating them. During the late 20th century, gemologists examining garnets from East Africa began noticing something unusual while studying stones from Tanzania and neighboring regions. Under daylight, certain garnets appeared muted, often grayish-green, olive, or sometimes slightly bluish. Yet when the same stones were moved beneath incandescent lighting, something remarkable happened. The color shifted. Green transformed into deep red. Olive turned into violet. Some stones even displayed dramatic transitions between teal and raspberry tones. The gemstone itself had not changed. The crystal structure remained exactly the same. What changed was the light interacting with it. These stones are now known as color change garnets, and their unusual optical behavior is caused by trace amounts of vanadium and chromium within the mineral lattice. These elements absorb and reflect different wavelengths of light depending on the lighting environment. In natural daylight, which contains a higher proportion of blue wavelengths, the stone reflects greenish tones. Under warmer incandescent light, where red wavelengths dominate, the gem suddenly reveals an entirely different color palette. The effect can be striking, sometimes appearing almost like two completely different gemstones occupying the same crystal. For collectors, this phenomenon holds a particular fascination. Unlike treated stones whose colors are enhanced artificially, color change garnets display their transformation purely through natural chemistry. Every shift in color becomes a demonstration of how trace elements inside the crystal interact with light. Yet despite this remarkable property, these stones have remained relatively obscure outside specialized gem circles. Part of the reason lies in rarity. True color change garnets with strong transformation are uncommon, and deposits capable of producing them consistently are limited. East Africa, particularly Tanzania, has become one of the few regions known to yield such stones. And because each gem reveals its transformation only when viewed under different lighting conditions, their most dramatic characteristic often remains hidden until someone decides to test it. That moment, the instant when a gemstone unexpectedly changes color, is often the point when collectors begin to see it differently, not simply as a garnet, but as a crystal capable of displaying two completely separate personalities. And once that optical illusion becomes part of the story surrounding a gemstone, it rarely remains a secret for long. Ranked fifth, Mahenge spinel, the mine that burned bright, then went Kia. Gemstone markets rarely react quickly. Most stones spend decades building recognition before collectors begin treating them as truly exceptional. But every so often, a discovery appears that moves far faster than anyone expected. That moment arrived in the early 2000s in a remote region of Tanzania known as Mahenge. Miners working the area began uncovering crystals with a color that immediately caught attention. Unlike the deeper tones of traditional rubies or the softer hues of many pink gemstones, these stones seemed to glow. The color was intense, bright pinks, vivid reds, sometimes described by gem dealers as neon-like under natural light. At first, the material caused confusion. Many stones were initially mistaken for ruby because of their strong red saturation. But gemological testing soon revealed something different. The crystals belonged to the mineral species spinel. Spinels had historically lived in the shadow of ruby for centuries. In fact, some of the most famous rubies in royal collections, such as the Black Prince's ruby and the British crown jewels, later turned out to be spinel. But Mahenge spinel changed how collectors viewed the entire gemstone family. The colors emerging from the Tanzanian deposit were unusually vivid, often displaying a brightness that rivaled or even exceeded many rubies. And unlike ruby, spinel tends to form with fewer internal fractures. This allowed many Mahenge stones to display remarkable clarity alongside their intense color. Within a short time, the gemstone began attracting serious attention among collectors and dealers specializing in rare-colored stones. Yet the story of Mahenge spinel took another turn that made it even more intriguing. Production slowed. Mining activity in the region continued, but the early surge of high-quality crystals became increasingly difficult to replicate. Some of the finest stones appeared during the initial years of discovery, when miners were first breaking into previously untouched pockets of the deposit. As those pockets were exhausted, the supply of top material began to thin. This pattern is not unusual in gemstone deposits. Many of the world's most famous stones, Paraiba tourmaline, Kashmir sapphire, Burmese ruby, experienced similar cycles. An extraordinary discovery, a brief period of remarkable production, and then a gradual tightening of supply. For collectors who follow gemstone geology closely, Mahenge spinel represents a classic example of that pattern. A deposit that revealed its most spectacular crystals early in its history. A gemstone whose reputation grew rapidly once those stones reached the market. And a reminder that some of the most remarkable gems do not emerge slowly over generations, but appear suddenly, burn brightly for a moment in geological time, and then grow increasingly difficult to find, which is exactly why Mahenge spinel now occupies such an intriguing place in modern gemstone collections. Because the story of its discovery is still recent enough to remember, yet already distant enough to feel like the beginning of a legend. Ranked fourth, Tsavorite garnet, the gemstone from a single geological corridor. Most gemstones appear in multiple places around the world. Diamonds are mined across several continents. Rubies have emerged from Myanmar, Mozambique, Madagascar, and Thailand. Sapphires appear in deposits scattered across Asia, Australia, and Africa. But occasionally, geology behaves differently. Sometimes a gemstone forms only under an extremely narrow set of conditions that occur within a specific geological corridor and nowhere else on Earth. Tsavorite garnet is one of those stones. Its story begins in the late 1960s when British gemologist Campbell Bridges was exploring remote regions of East Africa searching for unusual mineral formations. While surveying deposits along the border of Kenya and Tanzania, Bridges encountered vivid green crystals embedded within metamorphic rock formations. At first glance, the color was striking. Deep green, intensely saturated, and remarkably clean. For decades, emerald had defined what a valuable green gemstone should look like. But emeralds often contain internal fractures and inclusions caused by the conditions under which they form. Tsavorite appeared different. The crystals belonged to the grossular garnet family, colored by trace amounts of vanadium and chromium. And unlike emerald, Tsavorite frequently formed with exceptional clarity and durability. That combination of brilliance, vivid color, and strength quickly attracted attention among gemologists. Yet the true rarity of Tsavorite lies not only in its beauty, it lies in its geography. The gemstone forms within a very narrow metamorphic belt stretching across parts of Kenya and northern Tanzania. The geological environment required to produce Tsavorite, specific pressures, temperatures, and trace chemical elements, has proven extremely difficult to replicate elsewhere. In other words, the gemstone's entire global supply originates from a surprisingly small region of East Africa. For collectors who follow gemstone deposits closely, that geographic limitation carries an important implication. When a gemstone emerges from a confined geological corridor, the possibility of massive undiscovered deposits becomes less likely over time. Production may continue, but the boundaries of the deposit are already defined by the structure of the earth itself. That reality has given Tsavorite a unique position among green gemstones. It offers the color intensity often associated with emerald, yet frequently with greater clarity and durability. And it comes from a geological environment so specific that its origin story remains inseparable from the landscape that created it. A narrow belt of metamorphic rock stretching across East Africa. A region where the conditions deep underground align just long enough to create one of the most remarkable green gemstones ever discovered. And for collectors who appreciate gemstones shaped by both chemistry and geography, that kind of rarity carries a story that extends far beyond the gem itself. Ranked third, Tanzanian ruby, Longido, the rival that quietly entered the room. For more than a century, the word ruby carried a very specific geographic identity. Myanmar, the legendary mines of Mogok produced stones that defined what collectors considered the pinnacle of ruby color. Deep red crystals often described as pigeon blood. These gems became benchmarks, shaping expectations for what a truly exceptional ruby should look like. But gemstone history has a pattern. Every once in a while, a new deposit emerges that quietly challenges that long-standing hierarchy. One of those challenges appeared in northern Tanzania, near a rugged landscape known as the Longido region. At first glance, the stones looked familiar. They belong to the mineral species corundum, the same crystal family that produces both rubies and sapphires. But the geological conditions that formed these rubies were very different from those of Myanmar. Instead of growing inside marble deposits, many Tanzanian rubies formed within amphibole-rich metamorphic rock, a completely different environment deep beneath the Earth's surface. That difference in geology created a distinct character. The crystals often displayed deeper tones, sometimes darker red, sometimes slightly purplish, reflecting the trace elements present during their formation. Internal structures within the stones revealed the intense pressures and temperatures that shaped them over millions of years. To the untrained eye, they might simply appear as another ruby variety, but to gemologists and collectors who study the geological origin of gemstones, the Longido deposit represents something more interesting. It demonstrates how the same mineral, corundum, can develop dramatically different personalities depending on the environment that created it. And for collectors, origin matters. Because when a gemstone begins appearing in serious collections alongside more traditional sources, the conversation around it slowly begins to shift. Not as a replacement for Burmese ruby, but as another chapter in the global story of ruby formation. The Longido region remains far less famous than historic ruby mines that shaped the gemstone trade in earlier centuries. Yet its stones carry something those older deposits can no longer provide. New geological discoveries, new crystals emerging from the earth, and a reminder that even the most established gemstone categories can still evolve as new regions reveal what has been hidden beneath the surface. In a market long dominated by historic sources, Tanzanian ruby represents a quiet but unmistakable signal, a rival entering the room, not with dramatic announcements, but with the steady confidence of a gemstone formed under entirely different conditions. And for collectors paying close attention to the changing geography of rare stones, that difference matters. Ranks second, Mozambique Paraiba tourmaline, the market disruptor. Some gemstones earn recognition slowly. Others arrive with such an unusual appearance that the market reacts almost immediately. That moment occurred in the late 20th century when a new variety of tourmaline emerged with a color unlike anything collectors had seen before. The first discoveries were made in Brazil, in the state of Paraiba. The stones displayed an electric neon blue, sometimes shifting toward turquoise or green, that seemed to glow even under low light. The secret behind this extraordinary color lay in the crystal's chemistry. Unlike most tourmalines, these stones contain trace amounts of copper, an element rarely present in the mineral structure of tourmaline. Copper interacts with light in a way that produces intense, almost luminous colors that appear to radiate from within the gemstone. The effect was so unusual that early buyers initially struggled to believe the color was natural. As the gemstone entered international markets, demand surged rapidly among collectors and high-end jewelers. Yet the story did not end with Brazil. Years later, similar copper-bearing tourmaline crystals were discovered in Mozambique, on the eastern side of the African continent. At first, the news sparked debate within gemological circles. Could these stones truly belong to the same rare category as the original Paraiba material? Detailed analysis eventually confirmed that they did. Mozambique had produced another deposit of copper-bearing tourmaline, one capable of displaying the same neon-like glow that had already captivated collectors worldwide. For the global gemstone market, this discovery created a new chapter in the Paraiba story. The Brazilian mines had already become extremely limited in production, with high-quality stones appearing only rarely. Mozambique introduced a new source, but not an unlimited one. The deposits remained relatively small, and top-quality crystals were still difficult to find. What mattered most was the visual impact of the stone itself. Even among experienced collectors, few gemstones command attention the way Paraiba tourmaline does. Its color seems to behave differently from most other gems, appearing almost illuminated rather than merely reflective. Because of that distinctive appearance, Paraiba tourmaline quickly established itself as one of the most recognizable colored gemstones in the world. And the Mozambique deposits ensured that Africa became part of that story as well. A gemstone defined not just by rarity, but by a color so unusual that it reshaped expectations for what tourmaline, and perhaps any gemstone, could look like. Which is why, when collectors discuss stones that have disrupted traditional hierarchies within the gemstone market, Paraiba tourmaline is almost always part of the conversation. Yet even this remarkable discovery is not the rarest gemstone on this list, because the final stone exists under geological circumstances far more unusual than any other deposit mentioned so far. A gemstone found in only one place on Earth. In first place, Tanzanite, the one-location miracle. There is a simple question gemologists sometimes ask when evaluating a gemstone's long-term rarity. Not how beautiful it is, not how expensive it is, but something far more fundamental. How many places on Earth produce it? For diamonds, the answer spans continents: Russia, Botswana, Canada, Australia. Even the rarest diamonds emerge from multiple geological systems scattered across the planet. But one gemstone on this list follows a completely different rule, because its entire existence depends on a single strip of land beneath the slopes of Mount Kilimanjaro in northern Tanzania. A geological corridor only a few kilometers wide. That gemstone is Tanzanite. When it was first identified in the late 1960s, gemologists quickly realized they were looking at something unusual. The crystals belonged to the mineral zoisite, yet their color behaved unlike anything previously seen in the species. Viewed from one direction, the gemstone appeared deep blue. Turn the crystal slightly, and the color shifted toward violet. Rotated again, and flashes of burgundy began to appear within the same stone. This optical behavior, known as trichroic pleochroism, means a single crystal can display three different colors depending on the direction of light passing through it. Few gemstones exhibit such dramatic optical complexity, yet the real mystery of Tanzanite lies deeper beneath the surface. The geological conditions required to create it appear to be extraordinarily specific. Heat, pressure, and trace chemical elements had to combine within a narrow metamorphic belt formed hundreds of millions of years ago, when tectonic plates reshaped this part of East Africa. And despite decades of exploration across the globe, those same conditions have never been replicated anywhere else. No second deposit, no parallel geological system, just one location. For collectors who study gemstone origins, discoveries like this occupy a special category. They represent what geologists sometimes describe as a single occurrence mineral event, a moment in the planet's geological history that happened once and left behind a limited number of crystals as evidence, which means every Tanzanite gemstone circulating today traces its origin back to that same narrow corridor beneath Kilimanjaro. The same rocks, the same geological accident. And when collectors consider gemstones capable of standing beside the most celebrated stones of the modern era, that kind of rarity carries a meaning that goes far beyond market trends. Because beauty can appear anywhere, but a gemstone created in only one place on Earth belongs to a completely different category of rarity. For most of modern history, the gemstone market revolved around a handful of familiar names: diamonds, rubies, sapphires. But geology rarely follows the expectations of the market. Sometimes the most interesting gemstones appear in places no one was watching, formed under conditions that exist in only a few corners of the Earth. Africa has produced many of those discoveries, stones that remained obscure for years, sometimes decades, before collectors began recognizing what made them truly unusual. And the next discovery could already be waiting beneath another mountain range, in a deposit that has not yet been explored, which raises an interesting question. Among all the gemstones on this list, which one surprised you the most?